Greetings, math fans. All right, we are going to start our new chapter, chapter 6, and our first topic today is inverse trig functions. So this is chapter 6 and day 1. Inverse trig functions. Okay, so the first thing I want to talk about is what an inverse function is. So if I just talk about in general, which you guys already know, an inverse, when you want to have an inverse function, you basically exchange the x and y values. Okay, so for example, if I have y equals 2x plus 4, and I want to find the inverse of that, I just say x equals 2y plus 4. Then I solve for y, so I get 2y equals x minus 4, divided by 2, y equals 1/2 x minus 2. Okay? So that's an inverse function. Let's talk about a little notation here. First of all, this, if I say f and then like there's a -1 there and x, this actually means an inverse function. So that little 1 right there is inverse. And then it's important, this is not an exponent. Please don't think this is 1 over f of x. Boo! That's bad. Okay, so it's not an exponent. All right, so let's talk about a little trig action here now. If I give you guys y is equal to sine of x, and of course the inverse is going to be x equals sine of y. So what I'm going to do is, let's give you a little t-chart here, an xy chart, and of course I used to pick values of x and then I get values of y. Well, I'm going to do the opposite now. I'm going to pick values of y and I'm going to get x. All right, so let's pick some values here. Negative pi over 2, 0, pi over 2, and pi. All right, and then I'm just going to calculate those values by plugging into the formula here, and I get 0, -1, 0, 1, and 0. All right, now you guys should recognize, is this an inverse function? Actually, it's not even a function. So this is not a function because x repeats. Okay, and that's actually really bad, right? X is not allowed to repeat here, because then so it's not a function. So actually, what I need to do here, math fans, is I need to restrict. So we need to restrict my y value. Okay, and so what I'm going to do here is I'm going to restrict it between here and here. All right, do you guys agree that if I restrict my y values between negative pi over 2 and pi over 2, x won't repeat? Okay, so I need to restrict my y value. All right, so this is the deal. When I restrict my y value, I have my range, because we have our domain range, and I'll talk about a range. Our range for this function, x equals sine of y, is going to be between negative pi over 2 and positive pi over 2. Okay, that's where the red is, right? And then, of course, my domain is going to be between -1 and 1. Okay, now it's a function. All right, that makes sense, everybody, I hope. All right, let's actually graph our inverse sine function with our new domain and range. Okay, so here I'm going to go back to x equals sine of y. And I know it's going to be, the y is going to be between negative pi over 2 and pi over 2. But let's pull out a few more points here. So negative pi over 2, negative pi over 6, 0, pi over 6, and pi over 2. So we can get a kind of an idea of what it's going to look like. And you got negative 1. Sine of negative pi over 6 is negative 1/2. You guys should remember all this stuff from a few chapters ago. 0, positive 1/2, and positive 1. So if I graph this nicely here, okay, I'm going to have pi over 6, pi over 2, negative pi over 6, negative pi over 2, 1/2, 1, negative 1/2, negative 1. Okay, and then I plot our points here. That guy, that guy, that guy, that one, and that one. Alright, so our graph is going to look something like this. Alright, now I want you to notice something pretty quickly here, math fans. First of all, there are no arrows here. And there's no arrows here. Because an arrow means it keeps going. Okay? And it doesn't keep going because remember, we restricted our range to from negative pi over 2 to pi over 2. So there are no arrows. That is what the graph looks like. So basically, when you're graphing all the other graphs, because you guys are going to have to recognize x equals sine of y, x equals cosine of y. So you have to graph all the inverse trig functions for sine, cosine, tangent, and all the reciprocal functions as well. Okay. Now, as opposed to trying to memorize that, what you need to do is you just need to pick points, and we're going to learn this in a little bit, the range for all the other trig functions. But you pick points and you graph it based on those points. Okay. So it's really not that bad, but you pick a few points, and I think you're kind of good to go with graphing these. You will be supplied with a nice little summary sheet of all the different inverse trig functions, so at least you can see what they look like. It would take me too long to graph each one of them here, but you will be supplied with that, the inverse trig functions in class. And I believe actually, if you go to, I'll just write this on here now, page 242 to 245, you have all your graphs of the inverse trig functions. Okay, so that's a good place to go. Now, real quickly, we've been writing everything as x equals sine of y. Well, it's not really very appropriate to write it that way. So what we're going to do is we're going to actually write it as y equals inverse sine of x, and that's what that means. Okay, inverse sine of x. Another way to write this is y equals arc sine of x. These are equivalent. Those are just some of the words that are used. Sine to the minus 1 and arc sine of x. Okay? All right. So, again, we have our restrictions for our range, and this is what I want to talk about next. So, restrictions for the range. So here's something I'm going to give you guys called a summary range chart. Okay, and so we're going to draw. This is like so important. In fact, here I'm going to draw a couple stars around here because that is so important to this chart I'm about to give you right now. Okay. So basically, if I want to talk about my range, all trig functions are in this first quadrant, and they are all positive. Okay. The following trig functions are negative in this quadrant, and it's going to be inverse sine, inverse cosecant, and inverse tangent. Okay, and in this quadrant are going to be inverse cosine, inverse secant, and inverse cotangent. All right, and so let's label a couple things here. This is going to be 0. This is pi over 2. This is pi. And we're not going to label this as 3 pi over 2. We're going to label this as negative pi over 2. Okay, because if you think about it, when we talk about the range, let's just review here. The range for y equals inverse sine of x, which we just talked about, the range was between negative pi over 2 and pi over 2. Okay, it doesn't make sense to have this 3 pi over 2 because you don't say between 3 pi over 2 and pi over 2, right? That doesn't make sense. So that's why we call that negative pi over 2. Okay, the cosine, y equals inverse cosine x, that range is between 0 and pi. So all your values for y are going to be between 0 and pi. All right, and I put these negatives and positives there because that's where, if you remember from All Students Take Calculus, in the fourth quadrant, of course, sine and cosecant and tangent, those are all negative. In the first quadrant, they're all positive, and in the second quadrant, cosine, secant, and cotangent are all negative. And just to kind of help you with remembering this chart a little bit, I always say in quadrant 4, the sines rule. Sines rule. Okay, so that's there's sine, 1 over sine, and sine over cosine. So the sines rule there. And here, in the second quadrant, the cosines rule. Okay, because you have cosine, 1 over cosine, and cosine over sine. So the cosines rule there. But that's just like a super important chart. Okay? And we're going to talk about this in a little bit, but I'll just kind of mention it now. If I give you guys a reference angle, and that's what's going to happen here, and I'm going to do this in red. But if I give you a reference angle and then I talk about these different quadrants, this is just going to be the reference angle. Okay, in the first quadrant. In the second quadrant, it's going to be negative of the reference angle because it's really based on that, negative pi over 2. And in the second quadrant, it's going to be pi minus the reference angle. Okay? Because that's kind of what you did, right? When I said it was pi over 6, you would say, oh, pi minus pi over 6. That would give me 5 pi over 6. That would put me in the second quadrant. Okay? Kind of the summary of all this is on page 246. 246. Who do we appreciate? The Yaks. Oh, sorry. Okay. If I go to just to kind of talk about a few of these here, if I say the tangent range, inverse tangent, well, you could see it's between negative pi over 2 and pi over 2. And aren't those values here asymptotes? Same thing with cotangent, inverse cotangent, the range is between, oops, that's a little messy, sorry, is between 0 and pi. And again, those are asymptotes. Okay, so that kind of helps you with those to kind of see the range, for those inverse trig functions. Okay, so let's talk about how we're going to use all this stuff now. And let's just start with a couple examples here. Okay, my first example here is inverse cosine. I want you to find the inverse cosine of 1/2. Okay, this inside here represents a ratio, which you guys know already. And the whole thing represents an angle. All right, so it's an angle. And the question, here's the question, is basically the cosine of what angle equals 1/2. So we're kind of going in reverse now, math fans. Okay, the cosine of what angle is 1/2? And wouldn't you guys say the cosine of pi over 3 equals 1/2? So that's what the answer to this problem is. The inverse cosine of 1/2 is pi over 3. I'm looking for I'm looking for that angle. That's what it is. So you're going in reverse. I want to point out one thing here. Remember, the range for cosine is between 0 and pi. Is this value between 0 and pi? It sure is. So that's why my answer is pi over 3. Okay, because technically, couldn't you give me an infinite number of answers? Isn't the cosine of, if I go over here in this quadrant, isn't it also positive? So isn't it the cosine of 5 pi over 3? Isn't that also 1/2? You guys should kind of know that from the chapter with radians. Well, of course, aren't there two answers per ratio, because it's positive both first quadrant and the fourth quadrant? So you guys could tell me, oh, it's 5 pi over 3, and couldn't I even add coterminal? Couldn't I say pi over 3, and I could add 2 pi, and I could say 7 pi over 3, and I could add 2 pi to this, and say 11 pi over 3. I could keep going. I could have an infinite number of answers. Okay, but because I've restricted my range, I only have one answer, and that's what my answer is right here, is just pi over 3. Okay. All right, so let's kind of let's do inverse cosine of negative 1/2. Okay, a little trickier. This one's negative here. So don't you guys agree that it's either in this quadrant or this quadrant? Well, which quadrant does it have to be in? Well, it doesn't have to be in this quadrant, because this right here, it's outside the range. So it can't be in that quadrant. All right. So my answer for this one is going to be, I'm going to show you a rule here in a second, but you're saying the cosine of what angle is negative 1/2? Well, the cosine of pi over 3 is positive 1/2. So math fans, pi over 3 is my reference angle. And if I'm over in the second quadrant right here, okay, if I'm over in this quadrant, isn't it just going to be theta prime, right? That's my theta prime is my reference angle. So this is going to be pi minus the reference angle. So pi minus pi over 3 is 2 pi over 3, which of course is in the second quadrant. So my answer to this problem, cosine of negative 1/2, or inverse cosine of negative 1/2, is 2 pi over 3, which is in the range for cosines between 0 and pi. So that's my answer, is 2 pi over 3. So let's come up with some steps now to make you guys successful in all these, to calculate your inverse trig functions. So this is steps to calculate inverse trig answers. Okay, the first step is you're going to determine the sine. Okay, and this is, I'm going to even write here, this is super easy. And the reason I say it's super easy is you just look at it. Look at it, okay? The sine. So, well, I'll do an example here in a second, okay? But you just look at the sign and say, gee, is it positive or negative? Okay? The second step is to determine theta prime. Determine your reference angle. Okay, and the third step, which is something really what's new today, is your answer must be in range. Okay, and let's talk about this nice little range chart. I kind of made a sketch real quickly before, but I get a little summary here. Knowing that this is for plus, so they're all here. Let's label this also. This is 0. This is pi over 2. This is pi. And negative pi over 2. Okay, so they're all, trig functions are in between 0 and pi over 2, and these are negative for inverse cosine, inverse secant, and inverse cotangent. And these are negative for inverse sine, inverse cosecant, and inverse tangent. Okay, and as I put on the paper before, this is going to be theta pi minus theta prime. This is theta prime, and this is negative theta prime. That's the chart you're going to use. Okay, it's got to be in the range. So again, this has got to be memorized, math fans. This guy right here has to be memorized. Okay, which is not a big deal. Just remember that it's you know, where cosine, secant, and cotangent are in the second quadrant, and sine, cosecant, and tangent are in the fourth quadrant. Okay. All right. So I got a bunch of examples I want to do with you guys, and you guys should be good to go after we do all these examples. All right. So let's start out. If I do inverse sine of 1/2. Okay. Let's look at the steps. The first step, determine the sign. Again, it's super easy. What I mean, determine the sign is that positive or negative? Well, that was positive. Okay. So this is the deal. If it's positive, I'm in quadrant 1. It's that simple. I'm on quadrant 1. Okay. So I determine the sign. I determine my reference angle. Well, again, you're asking your question. The sine of what is 1/2? Well, the sine. So this is our first step here is 1. Second step is reference angle is going to be pi over 6. Got to know that. Sine of pi over 6 is 1/2. The third step, it's got to be in the range. So look at the chart. And I even did number 3 already for you, really. So that actually is number 3 right there. Okay, so it's in the first quadrant, and it's, see what in the red, it's the reference angle. That's what all it is. So my answer just to this problem is, pi over 6. Okay, I know it's a little confusing at first, but really it gets easy after a while, as long as you are kind of following all these steps here. All right, let's just do inverse sine of negative 1/2. Okay, the first step is, what's the sign? Oh, there it is. Okay, so that one's negative. That's first step. Second step is, what's the reference angle? Well, I don't care about the negative. The reference angle is only based on the positive. So we actually have the same reference angle. Don't you guys agree the reference angle is still pi over 6? You're saying the sine of what is 1/2? Sine of pi over 6 is 1/2. Okay, and then the third step, it's got to be in range. So what's the range? Well, aren't we, since it's inverse sine, aren't we in the fourth quadrant? And then I just say, again, I'm using the red now. Okay, so I'm saying, oh, it means the answer is negative of the reference angle, so the answer is negative pi over 6. And that's my answer, negative pi over 6. Okay, let's try another one here. Inverse cosine of negative root 2 over 2. Okay, the first thing I'm going to do is I'm going to say, what's the sign? It's negative. And then I'm going to say reference angle. Well, cosine of what is root 2 over 2? It's pi over 4. And then I'm going to say the answer must be in the range. So I'm using both these values here, math fans, negative and pi over 4. And see this, let me highlight this. See this negative here? Okay, that's what I mean by that. I'm using the negative, and my reference angle is pi over 4. So I'm going to use this guy right here. I'm going to say pi minus pi over 4, which is 3 pi over 4. And that's my answer to that problem. Okay, that final answer is got to be in the range. And I'm going to stress this from now until the end of this chapter and beyond. It's kind of like Buzz Lightyear. That has to be, I'm stressing the range. Whenever you see an inverse trig function on the outside, inverse sine, inverse cosine, arc cosine, whenever you see that on the outside, your final answer has to be in the range. So in other words, if you told me inverse cosine of negative root 2 over 2 and you gave me negative pi over 4 or 5 pi over 4, which is out of the range, it's wrong. And by the way, this area right here, you will never have an answer in that area, ever. Okay, you'll never have 5 pi over 4 or 4 pi over 3 or anything like that. So you'll never have anything like that. Okay, so let's just do a couple more problems here, math fans. Just real quickly, if I did inverse cosine of positive root 2 over 2. Okay, again, whenever this is positive, I'm in the first quadrant. And then that means I just find the reference angle, and that's my answer. That's all I do. So you're going to say cosine of what is root 2 over 2? Oh, cosine of pi over 4. And that's my answer. Okay? It's really pretty easy. Let's do tangent. Here, so I'm gonna actually delete all this. Let me make a new chart here. Okay, so I just want to have our chart up on the screen here. So let's do a few more problems here. Inverse tangent of root 3 over 3. Okay, what's the sign? It's positive. So I'm just going to kind of say this out now as opposed to even writing it. We're just going to talk about it to make it kind of quick. Okay, it's positive. So what quadrant am I in? I'm in the first quadrant. It's really easy. If it's positive, I'm always in the first quadrant, and that's like the easiest thing because then it's the reference angle is actually the answer. And then your question is the tangent of what angle is root 3 over 3? Now you guys are used to 30 degrees because we talked about that many times that the threes rule in the first, when the threes rule here. So the tangent of 30 degrees is root 3 over 3. Really, most of my answers are going to be in radians. And so don't give me 30 degrees. Please tell me it's going to be pi over 6. Okay, and that's actually the answer to this problem. Pi over 6. Let's throw a negative in there. Inverse tangent of negative root 3 over 3. Well, it's the same reference angle, and the sign's negative. So let's go to our chart. Don't you guys agree I'm in the fourth quadrant? So my answer is negative pi over 6. Okay, it's that simple. Okay, let's do inverse cotangent of 1. All right, so you're going to say what the cotangent of what is 1? Well, that's kind of a nice one. Isn't that like the 45-degree angle or the pi over 4? Okay, so it's positive. Oh, the answer is pi over 4. Ooh, that's nice. How about inverse cotangent of negative 1? Okay, isn't everything the same? Isn't it the reference angle is pi over 4? Okay, but look at the quadrant we're in, math fans. Okay, aren't we in the second quadrant? So the answer is going to be pi minus pi over 4, which is 3 pi over 4. And that's the answer to that problem. Okay, as opposed to, let's do inverse tangent of 1. Well, positive. We're in the first quadrant. It's pi over 4. Okay, inverse tangent of negative 1. Okay, it's negative, so I know what quadrant am I going to be in? I'm going to be in the fourth quadrant. It's going to be negative reference angle. Okay, the reference angle is pi over 4. My answer is negative pi over 4. Notice the difference between these two. Okay, that's inverse cotangent. Same reference angle as tangent, right? They're both pi over 4, but cotangent is in the second quadrant, so it's pi minus pi over 4, which is 3 pi over 4. And tangent's in the fourth quadrant, and so that's just negative of the reference angle, negative pi over 4. So that's what you have to do. Just remember, follow those steps. First step being find the sign, which is just by looking at the value here. I mean, I can't say that it can't be any easier. If I say look at the sign, you're looking at this negative right here, math fans, this negative right here, and say, oh, gee, it's negative. Oh, gee, it's negative. Okay, that's the first step. The second step is find your reference angle, which you guys should know how to do. Okay, and then the third step is kind of finding which quadrant you're in and saying either it's, if it's positive, it's just the reference angle. If it's negative, you got to say, oh, gee, is it pi minus the reference angle or is it negative of the reference angle? Okay? All right, let's do a couple more here while I have this chart up. Okay, inverse secant of negative root 2. Okay, first of all, what quadrant am I in, guys? Okay, don't you guys agree I am going to be in the second quadrant? Okay, so whatever my reference angle is, I'm going to be pi minus that value. Now, some of you guys are going, well, wait a second, Mr. Curtis, you never really taught us the, inverse secant. You kind of always showed us sine and cosine and tangent. Well, you're right. I told you, you only have a limited amount of brain space, in your or mind memory in your brain. So what we're going to do is we're going to rewrite this. Do you guys agree that's a ratio? That negative root 2 is really a ratio. So can I write this? What is this? Isn't secant just the reciprocal of cosine? Sweet. So I can do this. You guys agree with that? And, well, I'm going to rationalize it. So isn't that the inverse cosine of negative root 2 over 2? Ah, okay. I recognize that one. Okay, that one's pi over 4. So my reference angle is pi over 4. Okay, well, it's negative, so I'm in the second quadrant. Pi minus pi over 4 is 3 pi over 4. Remember, it's in the range. Okay, that was pretty mellow. How about inverse cosecant of 2 root 3 over 3? Okay, again, kind of brutal. I'm going to switch around. How am I going to call this inverse sine of 3 over 2 root 3? So if I rationalize that, which you guys should be able to do, I get, and even recognizing that's a root 3 in there, okay, that's root 3 over 2. Okay, so again, you're going to ask yourselves, the sine of what is root 3 over 2? And it's going to be pi over 3. Okay, so my reference angle is pi over 3. And guys, whenever it's positive, that is like super easy because that's just the reference angle. That's it. So my answer is pi over 3. Okay, it's really, really easy. Now, the only thing you have to kind of be a little careful about, see how I'm kind of doing the reciprocal here and I'm kind of figuring things out. If I give you inverse cotangent of negative root 3, some of you guys might want to switch around to inverse tangent. And if I do 1 over that, I rationalize it, I get negative root 3 over 3. And then you'll say, oh, well, the 3's rule, okay, so isn't this 30 degrees or pi over 6? So my reference angle is pi over 6. And I know you're tempted to say, okay, now it's just negative pi over 6 because it's tangent. But math fans, this was my original problem. Okay, it's the only one that's a little weird because all, like, the secant and the cosine go together and the sine and the cosecant go together. But tangent and cotangent are opposite quadrants. So you have to use the original value here. And that's why my final answer to this problem, it's pi over, reference angle is pi over 6, but we're using pi minus pi over 6 because it's originally using cotangent. So my answer is 5 pi over 6. Okay, so that's for the original problem. Okay, that's the only tricky one. Now let's do one more. I'm going to fit it right in this nice little friendly box here. Inverse secant of negative 1/2. Okay, well, I'm going to switch around to inverse cosine of negative 2. And then you say, okay, well, cosine of what is negative 2? And you're going to think, wait a second, inverse cosine of what is negative 2? And if you think a little bit, hopefully you realize, you're like, wait a second, isn't the maximum value that that number can have is 1 and the minimum value is negative 1? Think of it as a ratio, math fans. Right? If that is a ratio, like in cosine, isn't cosine x over r? Well, isn't x bigger than r? So that's impossible. So this value right here has to be, basically we're looking at the domain. The domain has to be between negative 1 and 1. So because it's not in the domain, we call this DNE, does not exist. Or do not eat, depending on if you're talking about those little silicon packets that come in electronics. Okay? But mathematically speaking, of course, it does not exist. All right, but that's only if you have, if you turn it into cosine or sine and it's not in the domain, you can't figure it out. All right? All right, very good. So let's talk about the calculator real quickly. All right, on our calculator, you're going to look and you're going to see inverse sine, inverse cosine, and inverse tangent button. Okay, remember that is also the same thing as arc of, if you see an arc sine, arc tangent, or a cosine. Okay, And just, just as you're typing in your calculator. So in radian mode, make sure you set your calculator radian mode. Okay, you're going to do inverse sine of 1/2. Okay, and just be careful of your parentheses. I mean, it automatically throws a parenthesis in there for you, which is kind of nice. But if you, of course, you're not going to get anything in terms of pi, but you are going to get, and your answer is pi over 6. But in your calculator, you're going to get 0.524. Okay, and if you type in pi divided by 6, you get 0.524. Okay, just kind of knowing your calculator a little bit. Then, of course, in degree mode, inverse sine of 1/2. Type that in there, and that'll give you actually a nice answer of 30 degrees. All right. The only weird one that you have to worry about, because you can even do here cosecant, inverse cosecant of 2. Okay, obviously you don't have an inverse cosecant button, so you got to type in back to the inverse sine of 1/2, which is, of course, our 30 degrees. Okay, so just make sure you know how to you do the reciprocal of that. All right. The only weird one, math fans, is well, first of all, arctangent of negative root 3. Okay, if I stick that in there, I get negative 60 degrees. Okay, it's pretty smart. It knows that. But if I do arc cotangent of negative root 3, okay, you're going to type in arc tangent of negative 1 over root 3, which is the same thing as negative root 3 over 3. But what that's going to do is that's going to give you, it's not going to give you the right answer. It's going to really give you negative 30 degrees. Okay, so why don't you go ahead and do that, type in inverse tangent at negative 1 divided by root 3. Okay, make sure you put a couple of, make sure your parentheses are all good to go with that. And of course, make sure you are in degree mode. But if you do that, you're going to get negative 30 degrees. Now that's not correct, is it? Or I'm sorry, that's correct for tangent, but it's not correct for this guy right here, for arc cotangent. Okay, so I want you guys to be aware of that. Don't just automatically assume your calculator is correct because your calculator doesn't understand what you're looking for. So kind of what you're doing here, math fans, is, which is the only tricky one, is you need your reference angle. And how do you get your reference angle? Well, you could just look at it and say, well, the reference angle is 30 degrees. That's actually really easy. Or you can just type in arc tangent of positive 1 over root 3. Because that actually gives you your reference angle, which is 30 degrees. And then manually you're going to say 180 minus 30 degrees, right? Or pi minus that reference angle. So the answer is 150 degrees. Okay, so let's just do a problem here. Inverse cotangent of 1.05. Okay, I'm just make up a random number. Let's actually make it negative because this is what we're truly doing here. Okay, so everything else is normal here. I'm going to write this as, I got to find my reference angle first. So my reference angle is going to be inverse tangent positive 1 over 1.05. Okay, and let's be in radian mode here now, because most of the problems we're doing are in radian mode anyway. All right. So it's going to be inverse, go ahead and type in your calculator, inverse tangent of 1 divided by 1.05, because it's 105, and I like 105. My answer comes out to be 0.7610. Okay, that's my reference angle. And you guys remember, cotangent, we're in this quadrant right here for negatives. And so isn't that just pi minus that value? So type in pi minus the answer. So pi minus the answer gives you 2.3806, and that's your final answer. Okay, so it's the only one is tricky is cotangent of a negative. Everything else is the same. I mean, I can type in inverse secant of 2.658. Well, we'll make it negative. And so you're literally going to type in the cosine, inverse cosine of 1, negative 1 over 2.658. Because remember, guys, these are just ratios. Okay, so you're allowed to take the reciprocal of a ratio, as opposed to if I said what's the cosine of, or let's say the secant of 30, that's not cosine of 1 over 30. That's bad. It's 1 over the cosine of 30. Okay, so anyway, inverse cosine of negative 1 divided by 2.658, that gives you 1.9565. All right, which of course, you guys, if looking at the chart here, isn't pi over 2 half of pi, which is about 1.6. Okay, and then of course that's just a little bit more, so that makes it in this quadrant right here. Okay. All right, so that's using your calculator. Okay, I've got one more thing I want to talk about. I know this is kind of a long lesson here, but there's a lot to do today. Okay, so now let's do some special cases for inverse trig functions. So let me start out here, math fans, with let's talk about our first case here. Okay, our first case is going to be where the arc or the inverse is inside. This is what I mean by this. I'll say the sine of the arc cosine of 5 over 13. Okay, now I know some of you guys are going, what? I don't know what that angle is, right? We never covered an angle like that. Well, here's the deal. What I'm really asking is, I'm finding the sine of some angle that I will never know. Okay, so this is kind of like a theta here. It's like sine of some theta. Well, what we're going to do is we're going to draw a picture. And that picture, this guy right here, is based on that arc cosine. So we already talked about our range chart, okay? And we know cosine is going to be in these two quadrants. It's negative here and it's positive here. Okay, well this is positive here. So when I draw my picture, I'm going to draw it in the first quadrant. So we know cosine is x over r, so 5, 13, and then of course this is a 5, 12, 13 triangle. Okay, and then this is my theta. So I don't know what that angle is, but I know what the triangle looks like, and then I can say, hey, what's sine of that? What's sine of that? Yeah, that theta, and sine of theta is y over r. So the answer to this problem, then, it's going to be 12 over 13. So that whole answer is 12 over 13. That's how you do that problem. Okay, but notice when I said again that the arc is on the inside. Okay, we're going to cover that for the second case where the arc is on the outside, but now the arc or the inverse trig function is on the inside, so it's a sine of some angle. Okay? All right, so let's try another one here. Sine of the arc cotangent of negative 3/5. All right, so again, it's the sine of some angle that I don't know. So I need to make a sketch. Well, it's arc cotangent and it's negative. So do you guys agree that arc cotangent negative is going to be here? Right? Because of cotangent goes with cosine, right? It's cosine over sine. So just again, looking at the range chart. And then, of course, you know cotangent is the xoi. So it's going to be negative 3 and 5. And then this is going to be using Pythagorean theorem, root 34. Okay, so this is my theta, and then I say, well, what's sine of that angle? Well, sine again is y over r, so it's 5 over root 34, which is 5 root 34 over 34. Okay, once again, I'm going to point this out. It's on the inside. Okay, the inverse trig function, arc cotangent, is on the inside. Those are kind of easy. So the key to these problems, math fans, the key, and you guys know what a key looks like. Okay, the key is you got to draw a picture. Okay, that's huge. So you draw, basically you're drawing your triangle. Okay, and you're making sure it's in the right quadrant. All right, because again, that arc cotangent dictates that it's in that quadrant. Now, if this, let's say it was arc, instead of that, I'm not going to do the whole problem, but let's say it was sine of the arc tangent of -3/5. Well, that means you draw the picture in this quadrant here. Well, maybe I will do the whole problem. Okay, if you draw it in that quadrant, so you know it's the yax, so it's -3, 5. And then this is going to still be √34, but now when I take the sine of that, it's y over r, so of course this 3 is going to be negative here, right? So it's -3 over √34, which is -3 √34 over 34. Okay? So again, this dictates where you draw it, and then you find your theta by just using your ratios. Okay? So that's pretty mellow. That's our first special case. Let's do it where the arc is on the outside. Okay, so the arc or inverse is on the outside. Okay, this is actually more difficult. I'm just going to put it out here. More difficult. Because the other one's easy. You just draw a picture and then kind of get your ratio. All right. I'm going to make a huge point of this. In fact, I am going to put this in a bold red. Is the answers must be in range. Okay, when you see inverse cosine on the outside of I don't care whatever it is, your answer better be between 0 and pi. Okay? If it's not between 0 and pi, then your answer is wrong. I'm going to put an R next to your problem because it's out of range. Okay, same thing with sine. If it's inverse sine or inverse cosecant or inverse tangent, right, that better be between -pi/2 and pi/2. Okay, if it's not, if that final answer is not between those values, I'm going to put a big old R next to it. All right. And standing for a range, you're not in the range because you didn't give it to me between these two values. Very, very, very important. Okay, it's got to be in the range. All right, so let's start with a nice little friendly example here. I'll switch back to black so we don't scare everybody. Arc cosine of the cosine of pi/3. So let's just talk about, let's do it, let's do it manually first, okay? And then I'll kind of show you a little bit of a shortcut, and then I'll even show you even a better shortcut. No, probably really one shortcut here. What is the cosine of pi/3? So this is from chapter 3 when I first introduced radians, right? So this is like really, really easy. Cosine of pi/3 is reference angles, of course, 60 degrees. Cosine of 60 is 1/2. So do you guys agree this is 1/2? And then I ask, what is the arc cosine of 1/2? And this is like before, right? Now you're saying, hey, the cosine of what is 1/2? It's positive. So remember, we have our steps here. Our first step for this problem is look at the sign. So it's positive. Second step is find your reference angle. Well, the cosine of what is 1/2? And it's going to be pi over 3. You guys agree with that? And then the third step is use the range chart. And if I use the range chart, well, that's easy. If it's positive, it's a blow-off right here. It's just the answer is just pi/3. That's my answer. Now, some of you guys are looking at it going, wait a second. What the heck, man? It's the same thing. It's like it canceled it out. And you're right. It did cancel out. That arc cosine does cancel out the cosine. Almost all the time. Right? What's the main thing here? It's got to be in range. So if I do another problem, arc cosine of the cosine of 2 pi/3. Is that going to cancel it out? It sure is, because isn't that 2 pi/3 in range? Yeah, so my answer is 2 pi/3. Okay? Let's do another one here. Arc cosine of the cosine of 4 pi/3. So if you went, oh, cool, it cancels out, and you wrote 4 pi/3 there, okay, what am I going to do? I am going to, in big red letters, I'm going to write an R here and mark it wrong. Okay, because that is not in range. Cosine is between, inverse cosine is between 0 and pi over 2. Or, sorry, and pi. Right? And that's 4 pi over 3. It's greater than pi. So you guys, you need to understand that your final answer has to be between, in this case, 0 and pi. Okay? So you got just a little bit of work to do. Not a lot, but just a little bit. So let's talk about the work you do need to do. Well, again, we can kind of do it manually here. All right, let's do it manually one time, and then I'm going to show you kind of a little bit of a shortcut. It's kind of nice. Well, cosine of 4 pi over 3, do you guys agree? First of all, what's the sign of that? Okay, and, that's over here, right? 4 pi over 3, and, cosine of pi over 3, 60 degrees, that's 1/2. But, of course, it's negative 1/2. So it's arc cosine of negative 1/2. And now it's just what we did before, is arc cosine of negative 1/2. Well, the cosine of what is 1/2? So we got three things here. We got one is we got to determine the SIGN, which you'll look at it and go, oh, it's negative. The second is cosine of what is 1/2? Well, the reference angle is pi over 3. And then the third step is you go to the range chart. Well, of course, if it's negative and pi over 3, aren't you going to over here? So isn't it pi minus the reference angle, which is 2 pi over 3. So that's my answer to this problem. It's not 4 pi over 3, it's 2 pi over 3. Okay? And you're like, well, okay, that I can deal with that, right? If it's not in range, I have to kind of do a little bit of work. So let's talk about maybe a little bit of a shortcut here. Okay? And this is only when you have the same value. You have arc cosine and cosine. If it was like arc cosine and sine, you can't do that. If it's like it cancels it out, but not really. So let's talk about a little bit of a shortcut here if you have them the same like that. So let's actually do this exact same problem. Arc cosine of the cosine of 4 pi over 3. Okay, again, the same, arc cosine, cosine. We're going to do, our first step is you're going to determine the SIGN. So SIGN, and that's just basically doing all students take calculus. Okay, and of course 4 pi over 3 is over here. So do you guys agree? It's negative. That's the first thing you're going to do. The second step is you're going to find the reference angle. And guys, the reference angle is so easy, especially in radians. It's so easy. When it's in degrees, it's a little more, a little more difficult. But man, radians is awesome because what do? You literally look at the bottom number. So I know my reference angle is pi over 3. That's so easy. Oh. So if it was 10 billion pi over 3, what's the reference angle? Pi over 3. Really, really easy. Okay, and then the third step is use the range chart. Okay, and it's negative and it's pi over 3, so it's going to be pi minus pi over 3, which is 2 pi over 3. Okay, so we got the exact same answers before. This is just, again, it's a little bit of a shortcut. So let's do a couple more of these problems with the shortcut. We'll keep one right on here. Let's do, how about this one? Inverse cosine of the cosine. Once you remember inverse, same thing as arc, right? Inverse cosine of the cosine of negative pi over 3. Okay? Is that in range? No. That's really the question you always ask. So the question, because if it is in range, then you're done with the problem. You just say that's the answer. But the question is negative pi over 3 in range for inverse cosine. And it's not, so no. So that's why you have to do these 3 steps up here. Again, it's pretty easy. The first step is, what is the sign? Well, a couple things here. Isn't negative pi over 3 here? So isn't cosine positive here? Second step was the reference angle. Well, let's look at the bottom number. Oh, it's pi over 3. Okay. Third step, use the range chart. Okay, and if I use the range chart, It's positive pi over 3. So I'm over here, right? The first quadrant. Well, the answer is just pi over 3, right? There we go. So I could have done something a little bit simpler. Again, I'm just trying to use some prior knowledge here, math fans. Do you guys agree that this guy right here, cosine of negative pi over 3, what can I write that as? Cosine of pi over 3? Because cos is pos. So I really could have rewritten this problem, even before I started anything, as this. Okay? Is that in range now? Oh, it sure is. So the answer is pi over 3. So we got the exact same answer, just a little bit different way. Okay? Alright, so I got a bunch more here I want to do with you guys because I think it's good practice. Inverse cosine of the cosine of 20 pi over 3. Brutal! Well, I would probably do coterminal and bring it down to something more manageable. So I would subtract 6 pi over 3 times. So it's like subtracting 18 pi over 3. So this is equal to inverse cosine of the cosine of 2 pi over 3, right? So again, we're doing minus 18 pi over 3, which is 6 pi over 3, right? Or 6 pi. So again, we're doing coterminal. Well, okay, so we're at this point here. Is 2 pi over 3 in range? Sure is. Woohoo! 2 pi over 3 is our answer. Oh yeah. Okay, here's another one for you. Let's try a different trig function. Inverse tangent of the tangent of 5 pi over 6. Okay, is 5 pi over 6 in range for tangent? It is not. Tangent is between negative pi over 2 and pi over 2, so it's not in range. You got to do 3 steps. First step, let's see, 5 pi over 6. You guys agree it's over here? And what is tangent here? All students take calculus. Tangent's negative there. Okay. Second step, what's a reference angle? That's the easiest thing I could possibly give you, pi over 6. Third step, use chart. Okay, so if you use the range chart, it's negative, it's pi over 6. Do you guys agree tangent is down here? So it's negative theta prime. So my answer is negative pi over 6. Okay? Not too bad, right? Okay, let's keep going here. How about inverse cotangent of the cotangent of 5 pi over 6? Is that in range? Yeah, it is. It is in range, right? Okay, because 5 pi over 6 is over here, and cotangent is over here along with cosine and secant. So my answer is 5 pi over 6. Those are really nice when they're in range. Okay, but you're not going to get too many of those. Inverse secant of the secant of 3 pi over 4. Secant goes with cosine. Is that in range? Sure is. I know you're getting a little bored. Okay, but that's okay. Okay, so inverse secant of the secant of negative pi over 4. Is that in range? Nope. It's not in range. So please do not tell me it's negative pi over 4. You've got to do a little bit of work. Okay, first step, the sine, S-I-G-N. Well, do you guys agree that negative pi over 4 is over here? And its cosine, isn't cosine positive here? In fact, even before I go any further, math fans, cos is pos, but it also works with its reciprocal function. So can't you just do this? Ah, yes. And now we're in range. Okay, you got that no matter how you did it, right? Okay. Not too bad. Let's see here. Let's try a couple more. Let's do one that's not necessarily you don't have a reference angle. So let's do inverse sine of the sine of pi. Well, is that equal to pi? Well, no, because again, we're over here. Okay, and the range for sine is between here and here. So it's not equal to pi. Okay, so you got to do a little bit of work. And basically you're saying, it's kind of like doing it the old way because you have no reference angle. So you're saying, hey, what's the sine of pi? Isn't the sine of pi 0? So I have that. And then you go back to this problem and say, hey, the sine of what is 0? Right? And wouldn't you say it's the sine of 0 radians is 0? So it's equal to 0. So this whole thing, it's not pi, it's equal to 0. Okay? How about let's do that one for cosine? inverse cosine of the cosine of pi. Is that in range? Yep, from 0 to pi. So we're good to go. How about this one? Inverse sine of the sine of 2 pi. In range? No. But, can I just do coterminal? Can I write that as a sine of 0? Hey, alright. So my answer is 0. Okay. Let's do a few more here. How about inverse cosine of the cosine of pi over 105? What? Ugh. Oh, that's easy. Is that in range? Sure is. Isn't pi over 105 like almost at 0? So the answer is pi over 105. It's all in range. How about this one? Inverse cosine of the cosine of 104 pi over 105. Is that in range? Sure is. It's right about here. It's almost at pi. So it is 104 pi over 105. Okay? Couple more. Don't go away. Inverse sine of the sine of 12 pi over 25. Where is that located? Do you guys agree 12 pi over 25 is a little bit less than half, right? Because 12 and a half is half of 25. So 12 pi over 25 is almost half, but it's still in the first quadrant. So don't you guys agree it's 12 pi over 25? Okay, because it's in range. All right. Let's do. I've showed you all the problems where it's the same. So sine, inverse sine, sine, and cosecant, inverse cosecant, secant, cosecant. So they're all the same. But if I give you something like this, inverse cosine or the sine of 4 pi over 3. Okay, remember it doesn't just cancel it out here, math fans, because these are different trig functions. Okay, so you have to kind of do the old-fashioned way here, and it's not a big deal. I mean, again, it's sine of 4 pi over 3. What is that? Okay, well, it's sine of 60 degrees, and sine of 60 is root 3 over 2, but we're over here. So do you guys agree that this right here, again from chapter 3, I would say the sine of 4 pi over 3 is negative root 3 over 2. Okay, and then you do the inverse cosine of that. So remember what I said to do is look at the sine. That's easy. It's right there. So it's negative. What is a reference angle? So the cosine of what is root 3 over 2? Well, isn't it pi over 6? Right, 30 degrees. And then you have the negative. So negative pi over 6, and then I look at the range chart. And so I'm negative in pi over 6. Don't you guys agree I'm over here? Okay, because cosine is negative here, and the range chart says pi minus the reference angle, or pi minus pi over 6. So my answer to this problem, actually this top guy here, is 5 pi over 6. Okay, it's a little bit longer when these are different. Okay, these are different trig functions. A lot faster when it's inverse cosine to the cosine. So I tried to show you a shortcut. If they're different, there is no shortcut here, and you have to kind of do a little bit more work. And remember chapter 3 and, of course, chapter 6. All right, so real quickly, math fans, this unit right here, remember when arc is on the, and these are all problems where arc is on the inside, or arc is on the outside. Arc or inverse. This is outside. Okay. The stuff I did in the beginning was arc or inverse is on the inside. That's where you draw a picture. There's not really a picture here. Maybe a little bit for getting the range chart or figuring out all students take calculus, but otherwise it's a picture when the arc is on the inside. Think of it as Noah's got his ark on the inside, and you want to take a picture of that ark before he goes out to sail. Once it's on the outside, you're all in water and nobody's taking a picture of it. Okay, you're on land. You want to take a picture of it on the inside. So if it's in the inside, you're taking a picture. If it's on the outside, there's no picture because the ark's floating already. Okay. So anyway, that is it, math fans. I hope you kind of pick up on a lot of the stuff. It's not necessarily that
that easy, but it's not that brutal either. All right? Anyway, have an outstanding day, math fans. Adios. Goodbye.